Today I'll be telling you about my project called Influence Viz. We will be working in a machine learning context, and we'll start by defining our key terms. Influence is a term that describes the following. Given a test image, we want to quantify how impactful each training image is in making a prediction on that test image. Previous methods required retraining the neural net again and again, leaving out just one training image at a time. Obviously, this was a tedious and time-consuming process. Then came along the ICML Best Paper from 2017, titled Understanding Black Box Predictions via Influence Functions. This paper uses influence functions which were developed around 1980, but up to that point had not yet been used widely. The researchers developed complex math to dramatically quicken current methods with the goal of generating explainability of a model's output. They addressed challenges that previous work had not. Specifically, they were able to handle a broader problem space, including models that were non-differentiable, non-convex, and high-dimensional, using effective approximations. You may be asking yourself, this sounds amazing, so what's the problem with that? The problem is that the output is a list. It's purely text. Especially for image-based neural networks, this is non-intuitive. My project builds a visualization on top of this awesome work to make it more intuitive to use. Now, let's take a tour. Here we see the visualization. We note that there's an airplane selected in the middle, which we can tell by the thick green border around it. We note that we can select anything from the scrolling bar, like the toad right below it. If we go back to the airplane, we notice on the left are the most helpful images and on the right are the most harmful images. Below each training image, we've included the influence, which is a numerical indicator of how helpful or harmful that image was in making a prediction. We see something interesting. If you look at the first image on the helpful side, you note that it's almost the same image as the original image we currently have selected. Maybe this is an indicator that our test set is not well formulated. This gives a really cool insight that we can actually see what the neural net is thinking. I'd love for this project to be a continuous work in progress, so I'd love to hear any feedback that you may have.